Hello, welcome to Jorge Does Math. For inquiries, you can email me at jorge.rodriguez@lean6sigma.net. It is the purpose of this channel to introduce the concepts of math, stats, geometry, and physics to the audience. If you like the content, please subscribe to our channel. I promise you I will deliver great content in the following months to come. So hit the button below and become a subscriber to our content. So today we want to bring the concept of substitution integration. This is a very powerful tool to simplify integrals that seem to be complex, but by making the right substitution, immediately the integral becomes very simple, and we can take it to an integral that is very recognizable and doable. So in this example, we have the integral of sine of ln x divided by x dx. So the first thing that I need to recognize is that I have a function called ln x inside of a sine. So that looks pretty ugly, but I am actually safe by the fact that I have this function in the numerator being divided by x. So what I need to recognize is that the derivative of ln x is actually 1 divided by x. Therefore, I can make a very simple substitution, and then this integral becomes extremely simple. Typically, we use the letter u when we're making substitution. So I'm going to call a variable u. I'm going to call it ln x. I'm going to take the derivative of that variable u of x, which is 1 over x. And therefore, then if I find what du is, I'm going to recognize immediately that du is actually 1 over x dx. So what I have to be able to understand here is that this over here becomes exactly my function here. So I can make my substitution very simple by doing this. So I'm going to proceed then with rewriting my integral now in terms of my new variable. So I'm going to write the integral of sine of u, and then x dx divided by x, we just define that as du. So this is my new integral over here. Therefore, I have to now integrate this and recognize that the integral of sine is minus cosine of u plus my cheese. And then I have to come back and substitute the u for the variable that I had at the very beginning, which is minus cosine of ln x plus my cheese, and this is the answer to this integral. Okay, the next integral that I have for you in this video is the integral of x multiplying a polynomial that is circumscribed to a power of fourth. So how can we recognize whether this is an integral that can be solved using substitution? Well, the first thing that I need to see is whether the term that is inside my parentheses can be made to become what is outside of the parentheses. So I immediately see that if I take the derivative of 3x squared plus 1, that actually becomes 6x. Therefore, I do have an x at the outside of my integral over here, as you can see, multiply times dx. Therefore, if I take the derivative of what is inside, this will work. However, I'm still missing 6. Therefore, I can just use a very simple mathematical trick where I'm going to divide my integral here by 1/6. Apologies here. So we're going to take 1/6 on the outer, and then I'm going to multiply by 6. I haven't changed anything about my integral. Therefore, this integral now I can rewrite as 1/6 of the integral of 6x times 3x squared plus 1 to the power of 4 dx. Now, once I've done that, I can recognize that what my substitution is going to be 3x squared plus 1, which is going to make my du be equal to 6x dx. And I have those terms in my integral right here. And from this point forward, it's just a piece of cake. So let's just go ahead and rewrite my integral now in terms of u. So we're going to then make this integral be, and don't forget that we have, so you have to be careful here because it's easy to forget that you have modified the integral with this term 1/6. So let's keep that in mind as we rewrite this, and it's going to be the integral of the inside of the bracket, which we're now calling u, and is to the power of 4, and then cx dx, we are calling that du. And this is a very simple integral, again, that we can use the power rule to solve. So we're going to call that 1/6 of u to the 5 divided by 5 plus u cheese. Now, I need to return my original substitution. So this is going to be the final answer for this integral. We're going to take 30 at the bottom, 6 times 5, that's 30. And then inside the u, we're going to put 3x squared plus 1. And don't forget that this is to the power of 5 plus your cheese. And this is the answer to this integral. Okay, so we have one more integral for you. And this is going to involve 2 parts. So what we want to recognize here is that inside the sine function, we have 2x. So the derivative of 2x is actually 2. Therefore, we can immediately call a variable u. And in this case, I'm going to call a variable u. I'm going to call it 2x, and by doing that, immediately this becomes du is then 2 dx. So I'm going to use this substitution here that is going to enable me to go ahead and do that. So I can rewrite then my integral in terms of u by leveraging this initial substitution. So it's going to become the sine of u divided by the cosine of u, and then everything is going to be by du. So my integral now is in terms of the function du. Then the other thing that I need to recognize here is that cosine u actually derivates to minus sine u. So if we manipulate this integral and put a minus here and a minus here, then by calling a new variable v, what I have in the denominator of my function, of my integral, I can then again leverage substitution to simplify this integral. So I'm going to call v cosine of u. Therefore, the derivative of v is minus sine of u du. Okay? So I can find this right here in my integral. So I'm going to rewrite all of this now in terms of the new variable v. So don't forget the minus sign that I've been carrying here. So we have the integral of dv, and then at the bottom I'm going to have v, and this is a very well known integral, which is the ln of v plus arches. Now all I have to do is to return all of the substitutions, and my problem has been solved. So the first substitution that I'm going to return is going to be the ln of v, which we know now is cosine u plus arches, and then the second substitution is going to be the ln of cosine of 2x plus arches, and this is our answer. So I hope you have enjoyed the content that I brought to you today. Integration by substitution, a very powerful tool to simplify our lives when we have integrals. So in summary, try to identify a function that derivates to something that exists already integral, and if you can find that, then go ahead and do it. Thank you very much. Don't forget to subscribe our channel and be a member of this community. More content coming your way soon. Thank you.